Welcome to Wagner Academy as we take a look at the Chapter 3 review packet for geometry. Let's jump right into it, getting right into questions 1 and 2 here, following the directions I see here. So we're referring to this figure and trying to figure out which segment is skew to CD. So if something is skew to another, a segment is skew to another segment, if you extended those segments out, they would never cross and they would not be coplanar. So let's see, CD is right here. I'm going to use my highlighter for this. So here's CD. And of these choices, which one is going to be skew? Well, EF, if I had a segment there, that would actually be coplanar, because you could make a plane that would contain both of those segments right there, slicing diagonally through that figure. AE, this one, right here, if I extended that out indefinitely along with CD, neither one of those would cross, or they would not cross each other, and they would not be coplanar at the same time. So that looks like that should be my answer. Let me just check the others. So AB, yep, that would be coplanar with the front of the box here, and HG would be coplanar. Looks like that's the G down there, so that'd be coplanar with the bottom of the box. So which one is actually skew? This one is choice B. Number 2, which segment is parallel to AB? So let's erase what we had there. We're starting with AB. Would be this segment right here. And which one is going to be parallel to that? So now they are coplanar. So CD, this one right here, looks like that would be parallel. If you extended those out indefinitely, they would not touch, and they would be on the same plane, the front of the box here. BF, they would intersect right there at B. EH, they would be skew. They would not intersect, but they're not coplanar either. And FG, it looks like FG would be right here, and that would be skew as well to AB. So this one, it looks like CD is a correct choice, or DC. That is choice A for this one. Checking out numbers 3 through 8 now, we're going to refer to this figure, identifying the specific name of each angle pair. So 4 and 8, if I look at 4 and 8, it's not saying that these are parallel, but these are still cut by a transversal here, so we can say things about the angles. So 4 and 8, those two, since the lines aren't parallel, we can't say they're congruent, but they are still different types of corresponding angles. So that's a pair of corresponding angles. That's choice C. If I look at 5 and 11, do this one in green, 5 and 11, that would be with respect to this transversal and these two lines right here, C and D. Those would be on alternate sides of the transversal, and they're on the exterior of these two lines. They're not sandwiched in between, they're on the outside of those two. That would be choice A, alternate exterior angles for 5 and 11. It's the same picture again here, still referring to that same figure. So given that B is parallel to D, now if you look at the picture, that definitely doesn't look like that's the case in the picture, but let's assume that that was the case. And if the measure of angle 3 was 99 degrees, we're supposed to find the measure of angle 10. So I would look at this one and this one. Those would be consecutive interior angles. These two are supposed to add to 180. So that means that the measure of angle 10 would have to be 180 minus 99, and that would be 81. So 81, that's choice C for number 5. And number 6, given that, I'll go with green here. Now we're going to say C is parallel to D. It doesn't look like it, but we're going to make that assumption now that those two are actually parallel. And the measure of angle 8 is 73. So if this one looks like, yep, that's my 8 there, that's 73 degrees right there. Find the measure of angle 10. This one and this one now would be alternate interior angles. Those are supposed to be congruent. So alternate interior angles, if you have parallel lines, they're supposed to be congruent. And so we could say that choice B would be the correct choice for that one. So let me write choice B, 73 degrees, however. Let's have a look at number 7 and 8. Given that B is parallel to C, so now I'm using the same figure once again. I just have another copy of that here. So given that this and this are parallel, and the measure of angle 7 is 85. Now we're going to make that assumption. Find the measure of angle 1. So 7 and 1, those look like alternate exterior angles to me. Those are supposed to be congruent if you have parallel lines like we are assuming here. And so this one, since that's 85, we could assume that that one is also 85. So this one should be choice A. And then I'll go green here. If the measure of angle 4 equals 10x minus 6. So now I'm going to assume that this is the case. That's 10x minus 6, or 10x minus 6 degrees. The measure of angle 5 is 4x plus 18. So this one I'm saying is 4x plus 18. These two, if B is going to be parallel to C, these two would have to be supplementary. That's how we're going to get that to be the case. These two are consecutive interior angles. So it looks like we have an equation to solve that looks like this. 10x minus 6 plus 4x plus 18 equals 14. Well, that would equal 14x, but I should have it equal to 180. They're supplementary. So this is 14x. I was combining like terms in my next step already. I shouldn't have done that quite yet. And then subtract 12 from both sides. You get this. Divide by 14, so there's a minus 12 there. Divide by 14 here. And it looks like we should have our answer there, that x would have to equal 12. This one doesn't say to plug it back in and figure out what the angle measures are. We could do that if we needed to, but we're not requested to do that here in this one. So just x equals 12 for number 8. Number 9, what is the slope of a line parallel to the line containing 2, 5, and 6, negative 11? So if a line is going to be parallel to another line, their slopes must be equal. So if I find the slope of the line containing these 2 points, I've consequently found the slope of the line that's parallel to that. So we have a slope here is going to be y2 minus y1 over x2 minus x1. Here's x1 and y1. And here's x2 and y2. My first pair of coordinates, my second pair of coordinates. And so this would be negative 11 minus 5 over 6 minus 2. That's negative 16 over 4. That reduces down to negative 4. So this is going to have the same line, or the same slope for the parallel line. So parallel lines have the same slope. That means our answer has to be choice B on this one. Number 10 says to find the slope of a line perpendicular to the line containing these 2 points now. So we still have x1, y1, and x2, y2. And we can still find the slope of this line, this original line. Let's do that to start. So y2 minus y1 would become 6 minus a negative 9, which would be the same as 6 plus 9. And then we have 8 minus negative 2, which is the same as 8 plus 2. So we have 15 over 10, which we can reduce down to 3 halves. And then a perpendicular line that has an opposite reciprocal slope. So that means the slope is going to be, we take this, we flip it, and we negate it. Since it's positive, it becomes negative. So the slope of the perpendicular line would have to be negative 2/3. That is choice A. Number 11, I'm trying to find x and y in the figure. It's a little hard to read on my copy here. It looks like that is 8x minus 10. Looks like that's 6y minus 8 and x plus 18. So let's figure that out from here. It looks like we have this line and this line being parallel. Looks like it's kind of a weird little arrow drawn in here, but let me just draw that in a little more like I'm used to seeing it. So that and that are parallel. These 2 lines parallel. These 2 lines are also parallel. So there's some assumptions we can make here. It looks like we could say a few things. So the first thing I'm seeing here is that based on these lines being parallel, this one right here and this one would be congruent because these are corresponding angles. You have two parallel lines here and here, corresponding angles would be congruent. And then this one and this one, because of these two parallel lines, these two would be congruent by alternate interior angles. So you could, if you had to justify what you're saying, you could say that. It looks like we don't have to justify it here in this one. We just have to know how to use these properties. But because this one's congruent to this one and this one is congruent to this one, the first one would be congruent to the third one. So we could set up an equation like this. 8x minus 10 would have to equal x plus 18. From there you could solve for x. You could subtract x from both sides, add 10 to both sides. That would leave you with 7x equals 28. Divide both sides by 7 and you'd get x equals 4. Once you know that, it's pretty easy to find y, because it looks like this one and this one would be, the green one and the green one would be alternate interior angles with respect to these two parallel lines and this transversal. So we could say then that 6y minus 8 would have to equal 8x minus 10, but 8x minus 10 becomes 8 times 4. Now I can plug that in right there since I know that x equals 4. That means 6y minus 8 would equal 32 minus 10 over 22. If you add 8 to both sides, you get 6y equals 30. Divide by 6 and you've got your answer for y. Y equals 5 right there. Let's move on to number 12. Number 12 and 13, we're given these instructions. Find the slope of each line through the given points. So that's pretty straightforward. We've already done some slope stuff. It's your y2 minus y1 over x2 minus x1. So here's your labels for those. So we just have 4 minus 2 over 0 minus negative 1 would be the same thing as 0 plus 1. And this would be 2 over 1 then, or just 2 fully simplified. So this would be our final answer. Your m, your slope value, is 2 on that one. And then on this one, you could call this one x1, y1, x2, y2, just as before. We would have negative 7 minus 5 over 1 minus negative 2 would become 1 plus 2. That's negative 12 over 3. And that looks like it's negative 4 on that one. So number 13 should have negative 4 for your final answer for the slope. Number 14, let's take a look at that one. 14, 15, and 16, we're trying to determine if these lines are parallel, perpendicular, or neither. So we have to figure out the slope of Km and the slope of St in each case, compare them to each other. We know parallel lines have the same slope. We know perpendicular lines are opposite reciprocals. And if it's neither one of those, then you'd have neither. So same for parallel, perpendicular, opposite reciprocals. So let's figure out what we got here. Let's go Christmas time here. We got x1, y1, x2, y2. I'll use that for k and m. I'm going to do that on every one while I'm at it here. I'm going to use red throughout for line km. And then I'll use green throughout for S and T. So this would be my green x1, y1, my green x2, y2. Oops, I didn't want to use 2's yet down there. x1, y1, y1, x2, y2, x1, y1, x2, y2. Okay. So back to red. For km, we would have 6 minus negative 8, that's 6 plus 8, over 1 minus negative 1, 1 plus 1 in other words. 14 over 2 reduces down to 7. So let's compare that to the slope for ST. We would have 10 minus negative 6 is 10 plus 6. 2 minus negative 2 is 2 plus 2. That looks like that's 16 over 4. So it looks like this one would reduce down to 4. So if I look at that and I look at this, Those aren't the same, and they're not opposite reciprocals, so this one we would say neither. Let's do the same process here down on this one. For 15, -1 minus -5 would be -1 plus 5. 5 minus -3 would be 5 plus 3. This would be 4 over 8, which reduces to 1/2. For ST, we would have 3 minus 6 over 4 minus -2. That'd be 4 plus 2. So it looks like this one, we've got -3 over 6, which is -1/2. So these are opposites, this one and this one, but they are not reciprocals. Neither are they the same. They would have to be exactly the same signs as well. So this one is kind of a tricky one. At first you might think, oh, they're perpendicular, but this one would have to be -2 over 1, not -1 over 2. So this one is also neither. Those are neither parallel nor perpendicular. And then for 16, it looks like we've got 12 minus -4, that's 12 plus 4. And then 5 minus 1, that would be 16 over 4, which is 4. And then for the ST line, we would have 2 minus 3 over -4 minus -8 would be -4 plus 8. This would be -1 over +4. So if I look at that and that, these are opposite reciprocals. That means those two lines, were these the points, that would be perpendicular right there. Yikes. Writing a little too fast for that I and C there. Let me get rid of that, make that look a little nicer. Perpendicular. So let's take a look now at 17 through 19. These ones will go together, same instructions. For questions 17 through 19, write an equation in slope-intercept form for the line that satisfies the given conditions. This one's very easy because we start with a slope and an intercept. So we just have to plug it in directly into slope-intercept form, y equals mx plus b. So m's your slope, b is your y-intercept. And the y-intercept, that includes this sign. So if it's a negative sign, we're going to have a negative with a number there. So this would be y equals -4/9 times x, and it's a +2. And that's it. There's nothing else to do with that. So that's what we would put right there. For the next one, it looks like we're given a slope and a point. My suggestion when you have a slope and a point is to use point-slope form. So we would have y minus y1 equals m times x minus x1. This is your m value. We already know that right here. So that's going to go plug in right there. Just trying to get red there. There we Oh, come on. I thought I got the red. Selecting red. There we go. X1 and Y1 right here. So if I plug those values in, I've got Y minus Y1 would become Y plus 3. It's Y minus -3. This would be 3 times X minus 2. If I distribute the 3, that's 3x minus 6, and if I subtract the 3, that will change it so that it looks like slope-intercept form, which is what I'm trying to do, to follow the directions. This would be 3x minus 9 then from there. So you could use slope-intercept form, plug in your x and y value and solve for b as well, and then come back to the beginning, back to slope-intercept form and do that way. But my thought is that point-slope form is easier if you know that. So point-slope form, we can change point-slope form very easily to slope-intercept form. So my final equation there, 3x minus 9. And then if I have something like this containing 2 points, I'm going to need to calculate the slope first, and then I can use point slope form from there. So I'm going to say this is x1, y1, and x2, y2. And my slope, first of all, is going to be y2 minus y1 over x2 minus x1 would become plus 4. If I subtract a negative 4, that would be negative 3 over 12, which would be negative 1/4. So that's my slope, and I'm going to use this as my point in point slope. So this is my m, this is my x1, y1, going back to this form right here, point slope form, and then I'll change that to slope-intercept form. So y minus y1 would be y minus 2 equals m, which is a negative 1/4 right there, times x minus x1. So x plus 4 minus a negative would become a positive there. If I distribute that negative 1/4 through here and here, I've got negative 1/4 x, and then this would be minus 1, and then I add 2 to both sides, and I'm all done. I'm all set there. This would be negative 1/4 x, and that would become plus 1. That is in slope-intercept form. That is my final answer. So y equals negative 1/4 x plus 1. Number 20 and 21, we're trying to find x so that L is parallel to M. It looks like we got a couple that are a little hard to read here again. So this is, just to clarify, this is 7x minus 24. This is 5x plus 18. If they are going to be parallel, that means that these alternate exterior angles, which is what we have here, would have to be congruent. So we could say that this and this would have to be true if this is going to in fact be parallel to this right there. So I can very easily figure out what that x value has to be by solving for x with this equation. 7x minus 24 would have to equal 5x plus 18. That's the two expressions that I have there. And then from there, you could subtract 5x. It's a pretty simple algebra problem, I think. Add 24 to both sides. 24 is cancel, 5x is cancel. That's 2x equals 42. And divide both sides by 2. You've got your answer for x. X has to be 21. And then over here, it looks like we have consecutive interior angles. These add to 180 if these lines are going to be parallel. So this and this has to add to 180. This looks like it's 2x plus 12, if you can't read that. And this one is 5x minus 14. So that plus 5x minus 14 would have to equal 180. And if we combine like terms, we have this. And if I add 2 to both sides, that gets me 7x equals 182. I divide both sides by 7, and that leaves me with my answer of x equals 26. That would have to be the value of x if these two lines are in fact going to be parallel. If we can prove that they're parallel, that has to be what x equals. Number 22, we are drawing the segment. It looks like here, drawing the segment that represents the distance from E to segment AF. I think that's actually line AF, so there's tiny little arrows there from E to line AF. So for that, I'm going to get out my straight line tool here. I could extend line AF out a little farther. I could bring that out here. I'm saying if this were a line, when we talk about distance, remember we need to think about perpendicular distance. So we're looking for the shortest path from point E to line AF. What is the shortest path there? It's not along the diagonal here. It's going to be straight down like that. So if I have my vertical line tool, that should do it for me. So it's going to be that right there. Why don't I do this in a different color? I'll use red. So this red segment represents the distance from E to AF. And we know it's the distance, we know it's the shortest possible path because it's the perpendicular distance right there. And then for 23 and 24, it looks like we're going to find the distance between each pair of parallel lines. So if we have x equals -6 and x equals 5, I could draw a graph here to represent that. So I'll use, for my axes, I'll just use black. And looks like that'll definitely fit what I need there. And then I'll draw the lines in blue here. So x equals -6. 1, 2, 3, 4, 5, 6. That's where x always equals -6, no matter what your y value is. If you go anywhere along this blue line, your x value is -6. Likewise, over here, 1, 2, 3, 4, 5, this would be x equals 5 right here. Anywhere you go along that blue line, over here, the x value is always 5. It doesn't matter what y value you have, the x value is always 5. And so from there, if I want to find the distance between that, it's very easy if you have just vertical or horizontal lines. You just connect it with perpendicular distance. If it's vertical to start, connect it with a horizontal segment. If it was horizontal to start, you'd connect it with a vertical segment and just figure out how long that is. So it looks like we have from here to there would be 5, and then we'd have another, 6, we'd have another 5 over here. So the whole distance from here to here would be 11. So the distance from x equals -6 to x equals 5 looks like that is 11. And then a little more complicated here, the big guy, the one will take a few more steps to figure out when it's not just horizontal or vertical. So let's draw a graph for that. And that should do it there. Looks like that should be good there. Yep, that'll fit everything in here. Just going up by ones. And I have this would be a slope of -2, y-intercept of 5. I'm going to draw that one in blue here. So this one I'll have in blue. Y-intercept, start there at 5. 1, 2, 3, 4, 5. You have a point right here. If your slope is -2, that's like -2 over 1. Rise over 1 would be down to right 1 or up to left 1. That'd be the same thing as -2 over 1 would be the same thing as 2 over -1. So you could think of it either way. I would have all these points on that line. I'll connect these with a straight line in just a second. And then the green one, why don't I say the green one, that's going to be down here. Let's see, 1, 2, 3, 4, 5, that's right here. And same slope. So these are parallel. And I know that if I went down 2, I'd have to go right 1. That'd be -2 over 1. If I went up 2, I'd have to go left 1. That'd be +2 over -1. Both of those would equal the same thing in the end. So we'd have this. I don't have to draw all these dots in here. This is just to help me draw a nice straight line. So I could just have 2 dots as long as I was very careful to connect them exactly like I should. So I know that this is going to be one of my lines. That's the green one. And then this one look like that. So we're trying to find the perpendicular distance, the distance from a green line to the blue line, somewhere along here. And we need to use the steps. So we need to not make assumptions just because it looks like it's going to be from here to, I would say it looks like it's going to be from here to here. We can't just assume that that's actually going to be a point where it intersects exactly right there. We need to show the steps for this. So first of all, we need to figure out what are the slopes of these lines and then the slope of perpendicular lines to that. So I'm going to call this one line L. Actually, I'm going to call that one line M. That's the second one listed. I'll call this line L. Doesn't really make a difference. But I'm going to start for my red line. That's going to be the perpendicular line, the perpendicular segment connecting those two. So the perpendicular line I know would have a slope that's the opposite reciprocal of that, 1/2. So this is opposite reciprocal of -2 or -2/1. So we know that that has to be the case. So the equation of the perpendicular line if I use this point right here, if I start there, I'm going to start right there, and I go from there this way, I know my slope has to be 1/2, so I go up 1, right 2. I would do that again, up 1, right 2. So it looks like this is where they cross. I actually know that had to be a point on the blue line as well, because that pattern of down 2, right 1 had to work. But we need to, I need you to show those steps, how we're getting that, how we're getting to there on a test. So we've got the equation of the perpendicular line. Based on that, we started here. This is a y-intercept of -5. So we have a y-intercept of -5. We have a slope 1/2. If we combine those ideas together, we have an equation for the line that y equals 1/2 x minus 5. So I'm going to use this equation, and I'm going to use the green equation, and I'm going to set up a system of equations. I know that y equals both this and this. Let me circle the -5 there. There we go. Y equals -2x minus 5, and it also equals 1/2 x minus 5. So if I'm looking for where these two intersect, where the red, let me draw that in here, where the red line intersects the blue line. If I want to know that point exactly, that point precisely, and just double check, make sure that it is actually at 4, -3, like I seem to think, we can set those two things equal to each other. Substitute -2x minus 5 in for y. Replace y with what it equals here. So substitution, using systems of equations, I can set up this equation. -2x minus 5 would have to equal 1/2 x minus 5. Since y equals both of those things, they can equal each other. We can set them equal to each other. My preference is to get rid of the fractions first. So I'm going to multiply everything by 2. Every single piece by 2. If I do that, we've got -4x minus 10. The fraction goes away here. That's just x minus 10. If I add 4x, just notice the mistake I made there. I'm not actually using this one. I already know that intersection point. So I wanted to actually say not that part, but I'm looking for, that's why I color coded these things, so I would catch that. So I'm glad I caught that here early. So I'm looking for setting this part. I'm looking for this intersection point right here. If I set this y equal to this y equals 1/2 x minus 5, y equals -2x plus 5. That's the red and the blue intersection. That system of equations that will allow me to solve for that point right there, to know for sure that it is actually what I think, 4, -3. So this would be a plus 5 instead there. So now I have this and this equal to each other, and that would be plus 10 then. And so if I added 4x and added 10 to both sides, that would cancel there, that would cancel there. 20x or equals 5x, and then divide by 5, I would have that x equals 4. So that's what I thought. I thought it was out here at 4. And then let's just make sure that the y value is right there at -3. If we plug in this x value into my red equation, this one right here, y equals 1/2 x minus 5, let's see if I in fact get what I thought I should. That I thought I should get -3 for the y value. So y equals 1/2 times 4 minus 5. That means y equals, this would be 2 minus 5. That's what I thought it would be. Y equals -3. So I know for certain now that this point is in fact 4, -3. I knew that the point I had to start here, I purposely picked that as the y-intercept of line M as one of the lines here. So this was 0, -5. So now I have these 2 points, this point here and this point here. I can call that x1, y1, x2, y2, and use the distance formula to solve for the length of that segment. I could use the Pythagorean theorem as well. I could do, looks like 2 squared plus 4 squared equals this length squared. I'm trying to figure out how far is it from here to here. This is really what I want to know in the end. What is this distance right here? So I'm trying to figure that out using the distance formula. I can do that. And so I would have, I'll do this in just black here. The distance formula would be x2 minus x1 squared plus y2 minus y1 squared. So if I plug the values in that I have there, that would become, it's like 4 minus 0 squared plus -3 minus -5 would be -3 plus 5. So just like I had said, if you use the Pythagorean theorem, you get the same thing here with the distance formula. This would be 4 squared plus 2 squared. If you simplify what you got in there, in the parentheses, this would be the square root of 16 plus 4. That's the square root of 20. And if you had to get simplified radical form, you're going to take out anything that's a perfect square, any factor that's a perfect square. So we could actually separate this and say it's 4 times 5. 4 is a perfect square. You can pull it out as a 2, since the square root of 4 is 2. And you've got 2 radical 5. That would be an exact simplified radical form answer. Or if you had to give this as a decimal, let's say to the nearest tenth, you plug that into a calculator, you get approximately 4.5. If you plug the square root of 20 into a calculator, that's what we would get. So 4.5 approximately for your final answer, or 2 radical 5 as well. If you're not required to give simplified radical form, square root of 20 would be okay also. And so I believe that does it for us. We got our missing point right there, and we found the distance between those two values right there. So that was 2 radical 5, or approximately 4.5. So if you have any questions, you're one of my students, let me know. If you found any mistakes in the video that I didn't correct within the context of the video, please comment. If you're one of my students, expect to get some nice Wagner bucks for that if you're the first to comment. Hope that helped you. I hope you do really well on your test. I guess technically I should write this in up here, my final answer, since I've been doing that all along, in the little blurb or little blank right there, 2 radical 5, or approximately 4.5. So hope you have a great day. Hope you found that helpful. Let me know if you have questions. I'll catch you later.